I'm going to show you how to fix and diagnose an unusual failure with this Sony mainboard. I currently have it hooked into my bench test system, and as you can tell, I have no power. It's completely dead. Most commonly, a dead no power or boot looping fault is due to an eMMC failure. However, that won't be the case with this mainboard today. Let's bring the board to our workbench and take a closer look under the microscope. So the first thing I want to do is take a closer look at that Ethernet port. The first thing I'm noticing is right below, we have a highly burned component over here, and same as over here. And I believe those are resistor banks. If we take a closer look, we can see that all of these traces lead under these heat sinks. So let's remove it and find out what's underneath. Now that the heatsink is removed, we can tell these traces lead right to this processor chip. One of the things I didn't tell you earlier is while we were testing it, this processor was actually getting extremely hot. So hot, in fact, I could barely hold the board in this area. To confirm that it is shorted, we're gonna check some of the ceramic capacitors around it. The ceramic capacitors are supposed to have one side to ground and the other side goes to one of the connections underneath the BGA chip. If both of those sides are shorted to ground, that means our processor is shorted. Using the multimeter in beep mode, we're gonna check some of these caps, and they're not supposed to be shorted. See, we're getting about 3 ohms. Check this one. Also shorted, not shorted, shorted, we have a short. All right, so it looks like actually a lot of these are shorted. All right, we just confirmed we have a lot of shorts. Odds are very unlikely that all of those capacitors are bad. It is more likely that just the processor is shorted and needs to be replaced. So we're gonna use our BGA rework machine to go ahead and do that next. Now that we have a new chip installed, let's recheck those caps. All right, so let's start with these down here again. No beep. Let's check this one, no beep, no beep, no beeps. I think we also checked this big one up here, and no beep, but it is showing 65 ohms. And I'm just curious, so when we're in beep mode, it doesn't always show you the resistance. So when we are in resistance mode, we're getting 3.1 kilo ohms. So clearly our short is gone, which means we can go ahead and live test it again. Okay, I've plugged everything back in, and we still have a completely dead no power symptom. No lights from the standby lights. So this is the part we've never seen before. Using my thermal sensor, I'm gonna measure the temperature of the RAM bricks, starting with the 2 at the top. And then something I wanna mention is I've already done short checks on all the caps around the RAM bricks, and I did not find any shorts. So we're getting about 95 and slowly rising, 96. Now, if we take a look at this one down here, and then keep in mind the TV's only been on for about a minute or two. We're at 140. So it is significantly higher, 146. We're 50 degrees higher than the rest here. So clearly this RAM brick down here has got some sort of problem, even though we didn't find a short. It looks like the power surge traveled from our processor to the bottom RAM brick, so we're gonna have to go ahead and replace that next. Back to our rework machine. I guess we're live. Here we go. I guess I should have plugged in the flash drive. That's not looking good. That flash drive should be blinking. The RAM brick's not getting warm though. The optical light should be turning on, and it is not. I guess it's possible the other RAM bricks are also affected, but not in a way that we can detect. After further testing, we're no longer able to find any chips that are getting abnormally hot or any shorted components, so at this point we're gonna have to call this one a no fix. If you have any suggestion on what we should have checked, let us know in the comments below. Otherwise, thanks for watching, like and subscribe.